So let's write another piece of code which will add two numbers together, but it's going to add them in a bit more of an elegant fashion. So what we'll do is we'll go to the ASM folder, we'll put new file, and we'll call it addition.asm, and that's us ready to start. Now all of our code is going to start off at address 0x8000. We don't have the functionality for relocatable code, so we're always going to start at that address. So we're going to start off with the .code, and you'll notice here that whenever I type in the .cod, I get the options coming up here. Now you can turn these options on and off, and I'll show you how you can do that later. So if you just type in .code and you press space, then you can just get rid of it, okay? So it'll be 0x8000. Now we're going to add two numbers together, and we're going to get the numbers from a memory locations, and we're also going to store the result in a memory location. So we'll make some comments here. We'll write in, this is where the data is going to come from. And remember, the semicolon just tells us that it's going to be a comment, and that it's not going to do anything with this line. Now again, another directive is the .data, and it's going to be 0x B000. Now we could put this at, say, 8500, as long as it doesn't interfere with the actual length of the program. But what we can do is, to get off on a good start, we'll start putting the data in at this address here, 0x B000. So where are we going to get the data? Well, we're going to start off with the DS directive. So this is really define storage, and we've got our colon there, and we'll call it the first one, so we'll pull first, and we'll call it 1. So what's happening is we're setting aside one memory location, and we're calling it first. So the memory location we're setting aside is this 0x B000. And then we can set the other number, so DS second, and again one memory location, and then we'll put the result, DS result, one memory location. So 0x B000 will contain the first number, 0x B001 will contain the second number, and 002 will contain the result. So we're going to have to decide which numbers we're going to add up, okay? So again, we can use another directive, and it's the EQU. So this means equals. So we can say that the 5 is equal to the number 5, okay? So whenever we see the text that says 5, we associate it with the number 5. An EQU, and we can put in 3, and we will associate it with the number 3. Now we're ready to start the program. So we'll just make that a colon, semicolon. So program. Now we'll start it off with main, and we'll tab it in. So what we'll do is we'll put the number 5 into the first memory location. So we can do that with the data command. So we can say data 5, first, and data, and it will be 3, second. Okay, so this puts this is read the data command, and we're going to put whatever this is here into this memory location, and whatever this here into this memory location. But we know that this memory location here is this 0 cross B000, and this memory location here is 0 cross B001. And we're going to put the 5 into here, but what is 5? Well, 5 is just the number 5. So we're really saying just put the number 5 into this memory location, put the number 3 into the next memory location. And then we can start doing our actual core of our program. So we can load first into R0. So we can load the first number into register R0. We can load the second number into register R1. And then we can do the addition. And if we do the addition, it will be add R0, R1. So we'll get the final output, which will be R1 equals R0 plus R1. Now finally we want to store the results in memory, so we use the store R1, and we want to store it in the memory location result. And then we want to end the program, and that's us written a little piece of code in order to add two numbers together. So what we want to do is check and make sure it assembles okay. So we go to terminal, run task, and assemble file. And you can see I've actually been successful on the first attempt, which is quite unusual for me. So now that we've got the program here, what we can do is we can actually go in and have a look at it in the machine code. So if we head down to MC and we'll get into the addition.mc, and you can see that this is our program here. So if we look at just the very first couple of instructions, so the first one is 0200. So the 0200 is the data command, and it's going to put the number 5 into a memory location. So you can see here that this is really data, and it's putting 5 into this memory location B000. And then the next one is the data, and it's saying put the number 3 in the memory location 001. And then the next one is 0400, which is going to be the load instruction. And you can actually see these, as we've mentioned before, if you head in to the top level and you head into the instruction. Then if we head further up to the top here, you can see that the data command, here it is here, 0 cross 0200, and it's data #n into the address. So now we're ready to load this into the machine and watch it running. So let's go ahead and we'll do that now. So we will drop into the computer and then into the RAM, and then we will open up the file. So the file's in the MC folder and it's called addition.mc. Press open and you'll see that we've got the machine code in the file in the RAM. So whenever we run it, what we'll do is we'll run the tick frequency down at 4 Hz, so it runs really nice and slowly so we can see what's happening. So if I click tick enabled, you'll see what happens first of all is we're going to set up the stack pointer, and if you head down you can see everything working away. Okay, but we'll head back up to the top level. Now we're going to have a number placed in register R0 and another number in register R1. There it is, there's the 5, and then the next one is the 3. We add both of them together, we get the value of 8, and then it takes the number 8 and it places it into the memory location. So you can see here it's ended. So let's stop the actual ticking. We'll drop into the RAM and we'll see exactly where it's put the results. So the results are 0 cross B000. Okay, but this second set here of the RAM, it's halfway through. Okay, so it actually starts at 8000. So in order to get to 0 cross B00, we go from 8, we go to 9, and then we go to 10, which is A, and then the next one, which would be 11, which would be B. So we go 8, we go 9, 10, 11. So it's 3 further along. So we're going to get to 3000. Okay. So if I head down here and go to the 3000, we should be able to find it. 2D, and there we have them here. So we've got 5 in this memory location, 3 in this memory location, and the result is in the very next memory location. So that's us ran our first little interesting bit of code. We'll move on and we'll do another couple of pieces of code just to get us used to using the assembly language.